Well, several researchers were trying to find out why the speed accuracy or defeat slow happening in the rapid aiming task, and Woodworth in 1899 proposed two-stage process model. Well, his theory was based on the aiming analysis of the hand movement, and when he plotted the velocity against the time for the aiming movement, well, general trend was the bell-shaped curve. So we have peak velocity in the middle and decrease near the target. As the hand is nearing the target, you see these little bumps. So he thought, well, maybe there's two stages. First will be mainly pre-programmed initial impulse stage, where there's a smooth bell-shaped curve, and little bumps might be related to feedback. So we fill out the blanks. This is programmed stage. The first is the impulse stage, which is pre-programmed, and the later stage is the feedback control stage. So feedback-based phase, the later stage. About 100 years later, well, Smith proposed that for the movement less than 200 milliseconds, which is normally happening in rapid aiming task, 200 milliseconds is too small for visual feedback to occur. Remember, there was delay in visual processing and well, visual input and processing, which is about 200 milliseconds. So he proposed that if the aiming task is less than 200 milliseconds, it will be purely based on this impulse, not really related to the feedback phase. So his theory was impulse timing hypothesis. And in a nutshell, he proposed that the variability of the impulse is proportional to the velocity. So it says directly related to the amplitude and inversely related to duration of movement duration. And well, this indicates this one, which is the velocity. So you can actually see this case when you move slow or when you move fast. The variability of the endpoint is actually larger in a fast movement, and it says slower. And this endpoint variability is due to the variability of the impulse. So variability is expressed like this. Variability of impulse is greater, whereas for slow movement, variability of impulse is small. Well, what is impulse? Well, in the biomechanics, it is the area under the curve in force time graph. So if I apply the force to the paper with the time, the impulse represents this area under the curve. So as the speed gets higher, every time I do this back and forward motion, the impulse somehow be greater and somehow be less if the speed is high. But if the speed is slower, the impulse, the area under the curve, will be about the same shape. It's a constant shape. So it's a slower movement, and it's for the fast movement. Okay? So because of this, for the slower movement, well, the impulse variability is small, so we don't have to worry about the accuracy. But if we are doing the rapid motion, the impulse will vary a lot, so we have to take into account of the accuracy. So the object, the target widths have to be greater in order to take into account of that variability of the impulse. Crossman and Gudiv proposed different hypotheses to account for the speed accuracy trade-off, and it was termed as intermittent feedback hypothesis. And they were to account for the movement larger than 200 milliseconds. And what they proposed that in about every 100 milliseconds, the feedback will be updated and little sub-movement will be created. And the feedback correction is proportional to the distance left. So correction is proportional to the distance. So for example, for the first movement, the distance is A, so about 60% is corrected. In the second sub-movement, also the 60% is corrected, and the rest, and so on. So according to their hypothesis, the movement time is increased for the more distant object because there's more number of corrections involved. So number of sub-movements, number of sub-movements are involved for greater distance covered, whereas the shorter distance, the number of sub-movement will be less. Because each sub-movement will take about 100 milliseconds, the movement time will increase or decrease according to the number of sub-movements. So this is known as intermittent feedback hypothesis. In the recent days, 1990s, Maya et al. Proposed the mixture of those two theories. So this is also known as multiple sub-movement hypothesis. And Maya et al., Maya and colleague, did mix the Schmidt's theory, and Crossman and Gudiv theory. So they propose that initially this, there will be impulse, like the Schmidt's proposed, and in the later, this one or two sub-movement will occur to correct the error from the primary movement. So this impulse is the primary movement, and the later stage there will be secondary sub-movements to correct the error according to the feedback. In other words, the primary movement, the impulse is pre-programmed, and the later stage, the sub-movement is occurring with incorporating the feedback mechanisms. So it's pretty much similar to what Woodworth proposed 100 years ago, but it's more robust in the mathematical terms. So this example shows if the impulse was correct and just spot on the target, there will be no further feedback or correction will occur. But if the primary movement undershot or overshot the target, then the secondary sub-movement will happen to correct that error. This was also proposed because in most cases only 1 to 2 sub-movement was shown in the later stage on the velocity curve, Whereas the Crossman and Goody proposed that will be many number of bumps according to the amplitude of movement, but Maya et al. Said, oh well, we could only see one or two sub-movement, and that's why they proposed two-stage model like the Woolworths, but incorporating the Schmitz and the Crossman and Goody theory.